Welcome to SOS Electronic. Let's see how to remove passivation and restore full capacity in lithium thionyl chloride batteries. Lithium thionyl chloride batteries are widely valued for their high energy density, long service life, and broad temperature tolerance. However, these batteries are prone to passivation. Depassivation is a naturally occurring phenomenon in the batteries where a thin lithium chloride layer forms on the anode surface. This passivation layer acts as a protective barrier, reducing the chemical reactivity between the lithium anode and the thionyl chloride electrolyte. While beneficial for maintaining the battery's longevity and safety against hazards such as internal short circuits, passivation can lead to a temporary increase in internal resistance. This, in turn, may cause voltage delays or drops when the battery is first activated. Low battery levels, sometimes even below 50%, immediately after replacing the batteries, are not a sign of a defective battery, but rather a result of passivation, a state that limits self-discharge and extends battery shelf life to up to 10 years. To overcome this initial limitation, it's essential to depassivate the lithium thionyl chloride batteries before first use. Here is a guide on how to effectively remove passivation and achieve full operational capacity. Performing a quick depassivation procedure before first use ensures optimal performance and unlocks the full capacity of the battery. This simple step helps prevent unnecessary replacements or complaints by delivering the best functionality right from the start. Benefits of passivation are extended shelf life and enhanced safety. The passivation layer reduces the likelihood of unwanted reactions between the anode and electrolyte, preventing risks of overheating, rupture, or in rare cases, explosion. Drawbacks of passivation are voltage delay, voltage drop, and reduced capacity. Depassivation is a controlled process that disrupts the lithium chloride layer, restoring the battery's optimal performance. Proper depassivation is essential before the first use of lithium thionyl chloride batteries to ensure they meet the power requirements of the device. Depassivation techniques and a detailed step-by-step guide can be found on our website. The process may include pulse load application, gradual current increase, or rest period. To mitigate passivation effects, we recommend choosing quality products, avoiding prolonged inactivity, and storing in optimal conditions. A wide selection of lithium thionyl chloride batteries is now available on our website, ready to support your projects. If you are looking for different types of batteries, we are happy to supply them upon order under favorable conditions. If you are interested in more information, or if you need technical assistance in choosing suitable batteries, don't hesitate to reach out to us. We are here to help you.